Hello everyone, this is Alan Lynch. This is my Emerging Technologies and Learning presentation entitled Ready Student 1. It's a play off of Ernest Cline's Ready Player One. Ernest Cline wrote a book about called Ready Player One. It's about a dystopia. Economic turmoil has forced everybody to move into these large cities. As you can see in this picture, you have a lot of mobile homes that have been stacked on top of each other. Cool thing about it is that because life outside of the United States or inside the United States is so crappy, what they've done is they've created a simulated environment called the Oasis, and this is an environment where everybody kind of taps into to just release themselves and forget about what's going on around them. The main hero or character in this is Wade Watts, and he's got a lot of cool things going for him. A lot of cool things, tech as far as the classroom of the future. You can see here he's wearing a headset, like a VR headset, and a haptic glove here. And he's got a couple things I want to talk about that are really cool. First one is that he uses a free wireless network to access a virtual school platform. So school's free, he had to apply to get in, but he got on and access through the wireless network. He's been issued a hardware console to access this. This can be related to maybe like a laptop platform. He sits in a virtual classroom for lectures, just like he used to in his local school. But the difference is that he can visit historic sites during a lesson as a class. Because it's a virtual world, anything is possible. Anything can be created. He doesn't have to stay in the classroom for long. He has an avatar he uses to communicate. He walks around this virtual world, including the classroom. Given this avatar, it has facial scanning, so that when he is showing an emotion on his face, the headset is relaying that to his avatar. He's also using a voice. He can mask the voice if he wanted to. He can touch and feel objects using that haptic glove, which is pretty cool. You can use a virtual keyboard by moving your fingers across the screen there, and then you can also feel as if you were tapping on that virtual keyboard and getting that feedback. He's fully immersed in the simulation. The world around it's so vivid, realistic, that he forgets that he's actually sitting in an abandoned utility truck. This is the real world, and this is my classroom at launch site in Orange County Schools. This is a visual design classroom, and they have, as you can see in front of them, each student has a high-end computer, 2 monitors. They are building assets for virtual worlds in this classroom. So they're not using any headsets or any gear, but they are using high-end computers in order to get that to happen. The district has moved to one-to-one devices, which is good. Setting up that precedent means that the district is behind the notion that every student should have some sort of device to interact with the learning. So in this case, it's a Lenovo Yoga. It's a passive touch screen. It can be flipped over fully to act like an iPad. It is a consumption device. It is not powerful enough to do any kind of graphic intensive applications or AutoCAD or anything like that, but you can write Google Docs. It is connected to the network and has access to the internet, and it also has access to online documents as well. The biggest problem with this concept, though, is that it's limited to the amount of content that is available, and currently the content is primarily ebooks or e-textbooks, so it's not much better than a regular textbook, and that's what we're going to try to talk about today. This is Oculus Rift. It's a virtual reality environment, and what's cool about it is that it really looks close to the example in Ready Player One, where you have a student sitting in an environment surrounded by a virtual world and can interact with that environment. This would not be, however, a good idea for the classroom. It would look like a bunch of zombies are around and not safe. Here's another example. This is the HTC Vive, and again, here's an example of what the haptic device would look like in using that glove. So that's pretty cool that they have that. But what I want to talk about is the example I want to use is augmented reality. This is the Microsoft HoloLens. This is their developer edition device. Augmented reality is really good on the learning theory side because it gives you the situational learning theories and the constructivist approach to learning. It immerses you in learning. You have real world experiences or virtual world experiences that translate into skills in the real world. One thing about the device itself, the Oculus and the Vive all have to have, or both have to have, a high-end PC or workstation with a big graphics card to make it work. This, however, is using a mobile device platform, all contained inside the headset, and a lot less expensive. One of the examples I give in my tours is that of a math teacher teaching math but using it in a situation. This will be a great opportunity, a situation for a math student to engage. This is a CNC platform mills behind this virtual object. This will be found in a manufacturing zone. We have these at our school in our manufacturing programs. The machines in the very background there are Haas machines. They are very expensive. They're over $100,000 a piece. This virtual object could be simulated onto a virtual Haas machine, and a student can learn how math is translated into a cutting operation, let's say, on that actual machine there. This is one of the examples I do give in class as well, and this is biology. Here you have a HoloLens. You have 4 students or 4 people interacting with a skeleton. You can see the perfect application in biology. If this were actually superimposed onto a neighbor, half the students could be a skeleton, half the students can be working with that student in a biology situation. The example I give in my paper is of World War II. If you can imagine a history lesson, that's one of the things we're working on is history lessons inside the launch site. We're trying to produce those, and I'll show you that a little bit about that as well. But let's just say we go into our classroom, and immediately our device that we're using is tapped into this classroom network. All the walls around us are projecting a scene from a World War II London. We can hear German planes coming through, and we can see bombs being released and smoke and debris flying everywhere. After a minute or two, we see a military official coming from the wreckage. He's talking to the middle of our classroom, and we're interacting with the official, asking questions and really trying to develop or construct a sense of what it was like in this particular time period. So it's a great way of learning, immersing yourself for 40 minutes or an hour as far as the class time goes, and being able to learn by doing, and being able to remember that as if you were there, just like on vacation. I'm going to show you a few things we have at our launch site that help us create these virtual worlds. Here are 2 students in a motion capture suit. Here are a couple of students markering up another student in one of our motion capture labs. You can see the cameras around the top there. The idea is that in the motion capture lab, we're able to capture body, fingers, face, all at the same time. And what we're trying to do is create an emotional experience by telling stories with virtual characters. So we're starting out with history lessons, monologues. Take a historical figure, maybe like Thomas Edison. You go into a lab, you see Thomas Edison there. He's giving you his life story. That's all has to be created. This is one of the ways we use to create that. Here's another student. He's operating a laser scanner. This is a really cool device because what we can do with this laser scanner is we can take the scanner out into the real world, and we can scan an environment and bring that data back to our lab and build a virtual world based on real world data. So we can have an accurate to the millimeter representation of that virtual world. These are programmers, programming students. They are giving the functionality to the assets, the visual assets that we create. And we make a door, they make the door open and close based on the needs of the platform. This is a simulator, one of the simulators that we have here. This is using actual virtual reality, but gives an example of being able to take the data that we're collecting and then putting that into a hardware solution. In this case, we could do a forklift simulator and allow a student to get certification. But getting back to the augmented reality portion of it, the idea is that these students will be able to interact with a teacher and still be able to see their environment. So there's some benefits to this, and let's go over those now. All students will have the same access to educational platform no matter where they attend school, because each student will have the same curriculum and devices. The idea is that We want to give students an equal opportunity to education. I think a lot of that had to do with reasons behind Common Core, flat across the board access. But in this approach, you want to make sure you build a platform and make it accessible to every state, and then states can use that their monies to build stuff for that. Student learning would be interactive and immersive, giving students a chance to surround themselves with the sights, sounds associated with the given situation. In an augmented reality scenario, your visual aids, your three-dimensional models, your sights, your sounds really add to the lesson, and it fosters that learning, that applied learning. So augmented reality does that for us. Students will have access to simulated equipment that can be expensive to own and operate, just like that machine we saw earlier, that Haas machine. That's expensive. Not all school districts can afford to own the real machine, but anybody can have the virtual machine if as long as somebody has programmed it already, and that file can be shared. So imagine a TV production class in a rural area. They want to learn how to operate a film camera or a high expensive video production camera that they can't afford. Here is a simulated version of that camera. They can work with it. They can play with the iris. They can play with the focus ring, all that buttons on operating that system. And then when the time comes to certify, then we can rent the camera for that one day, certify everybody, and everybody has experience and certification based off that experience, that virtual experience. The cost of learning for secondary, post-secondary education can go down based on the reduced number of staff and faculty requirements, even as much as the cooling cost of cooling all the computers. Laptops they create heat. Computers definitely create heat. All that heat goes to the energy bill. You can lower the cost of energy bill by having low power devices being used as opposed to the workstations. And you don't have to buy those workstations or the video projectors. Augmented reality further connects students and teachers during the learning process through email and messaging systems. If you can imagine a heads-up display of playing any kind of video game where you have your health meter, your compass, those same kind of devices can be programmed to your screen, which you're looking at. You can get messages from maybe an all call saying you have a fire alarm or you have an emergency lockdown situation. All that can be done there. The really cool thing about augmented reality is that you can make your classroom whatever you want it to be. So you can add whatever scans you want to the walls, add video projectors, video screens, all on your walls. That's one of the ways of saving the money. Simulation companies are already developing products for military. There's a conference called ITSEC that happens every year in Orlando. This is where all the simulation companies will go and show their wares, and they'll show exactly what happens with augmented reality or virtual devices. But there are companies already making products. The trick is to get them to work with publishers to create products for K-12 and create more products so that schools have enough to adopt to that kind of device, because you really have to have the content. It's kind of a catch-22. You have to have the content before you can buy the devices. You got to buy the devices before there's a lot of content created for them. So let's go over some of the concerns. Some of the concerns rest with the fact that changes will have to be made and the expectations exist for our educational system. Right now, everybody expects to send their kid to a school. That student is watched all day, is taught maybe 7 periods a day, and then shipped back home. But, when we're talking about augmented reality, virtual reality systems, we're talking about a time where the student doesn't necessarily have to go to school. They can stay home and have just as much access to it. But that's a new paradigm, and that new paradigm is going to have to be ironed out between the parent and the community. Teacher training is not sufficient yet, and it'll have to be modified. As you change the way education is delivered, you have to change the mindset and the education of the teachers that are delivering that content. As we move from more towards an agent model, even in the AI standpoint of having a virtual teacher training you as opposed to a live teacher, then you're going to have to modify how the teacher in the room is behaving amongst everything. Schools will have to find new sources of funding as education costs go down from competition. Just like charter schools kind of remove some funding from local school districts, they're going to have to reorganize and figure out how to cut costs, and how to maybe reorganize their school system, maybe close a school or two, all around the changes in technology. So there is going to be some shift there, and they may have to lean towards more of building lab environments where students will come in for a short period of time, use a lab, and then go back home. And then finally, alternative education platforms impact local school districts. So we have to look at what impacts are going to be made to the school district in terms of maybe busing or managing the classroom. Even the classroom themselves would have to be redesigned for technology. So a typical classroom nowadays is designed for students sitting at desks for an extended period of time. But what does that look like in a virtual world? And maybe you're having a large platform simulation where you're in maybe more of a gymnasium type of environment, an open world where students are walking around and exploring as opposed to sitting in a small classroom. Finally, some recommendations for technologists, education technologists. First one is to build an open platform. Whatever we build, let's make it an open platform. Let's make it a platform that is standardized across the United States. Let's make it a nationwide platform for development, and that every state can build products based on government contracts or local contracts that fit within that platform. This is already done in the military. There are standards for military simulation. Those kinds of standards should be adopted and placed into the school system and behave accordingly. Leverage technology to sustain local schools. There's no reason why a school district couldn't give a laptop to a homeschooled child who's registered through the district. That would save building costs. Imagine if a district of my size builds probably 3 schools a year, 3 new schools, and then renovates maybe 2. That's a huge cost in education. And if we can keep students at home with their parents and leverage the technology by providing them laptops to access the school, and the virtual school especially, then let's do that. Let's keep that kind of thing. Develop more tools for publishers and developers. Just like Apple and Google both have tools for developers, we need to have an established developed tools for these virtual environments, these augmented reality environments. The more tools that we have, the more developers we'll be able to get, and make it easier for the publishers and developers to develop these tools. Then we'll have more products coming from those developers. And then finally, we have to launch a killer app. At some point, there has to be some kind of killer app. We've seen the sensation around Pokemon Go and the hordes of people playing that all around. That is a killer app for Nintendo right now. We need to have a killer app for education, some kind of course that could be taught using this app that is a common course throughout all of K-12 and can be adapted rather easily. And that would prove the case for augmented reality in the classroom, and therefore be able to sway administrators to or persuade them into adopting that as well. So that's it. I'd like to thank you for listening, and if you have any questions, please message me in the learning management system. Thanks.